This video will walk you through graphing linear functions. So let's start with our first linear function, y equals 1 half x minus 3. I'm going to go through two different methods on how to graph this function. Method 1 is to use the slope and the y-intercept, since this equation is already in slope-intercept form. The slope, as you recall, is 1 half, and the y-intercept is the constant, negative 3. Now, since the slope is 1 half, we know that we can reinterpret this positive 1 over positive 2 as a negative 1 over negative 2. We're going to use this when we try and find our points. And of course, the y-intercept is negative 3. So, we first plot the y-intercept, then use the slope to determine a second point. So let's follow those instructions. Plot the y-intercept. The y-intercept is negative 3, so let's go over to our graph and find y equals negative 3 and plot that point. And now we're going to use the slope to find our second point. So let's use this first interpretation of the slope, 1 over 2. So a positive 1 over positive 2 means as y increases by 1, x increases by 2. So from this point, we're going to increase y by 1, and we're going to increase x by 2. 1, 2. And that will get us another point. Now at this point, we could be done because all we need are 2 points to graph any line, because 2 points define a line. But just for fun, we're going to use this different interpretation of slope to show you that they are both valid. And at times, you're going to have to reinterpret a positive slope like this, 1 over 2, as another positive slope, but interpreted as two negative values. So, negative 1 over negative 2 tells us that as y decreases by 1, x decreases by 2. So let's decrease y by 1, let's go down 1, and then decrease x by 2. 1, 2. And that will get us to a third point. And notice this point also lies on this line. Now we have 3 points, and we could continue this in both directions if we wanted to plot all possible points on this graph, but this should be enough. We can use a straight edge and graph our line. And that's method 1 for graphing linear functions. Now let's use a different method. So we're going to use the same function, same line. We're going to come up with some of the same exact points, but we're going to use method 2, which is to use a function table. This becomes very, very useful when we expand our knowledge of functions to nonlinear functions, such as exponential and quadratic functions. So what do we need to do? We need to make a function table. So I made a function table here, and I just put in some values for x, 0, 1, 2, 3, and 4. I plugged those values into the function, and I got out negative 3, negative 2.5, negative 2, and so on. Now, I could use these values, but if you notice, some of them are slightly, they're not imprecise, but graphing them is going to be imprecise. So we could find the point 0, negative 3. Here's 0, negative 3. But where exactly is the point 1, negative 2.5? Let's see, 1, negative 2.5. It would be approximately here, but we would prefer points that are more identifiable. So I've made a second function table, and notice I've chosen different values. I chose negative 4, negative 2, 0, 2, and 4, and notice the outputs that I get when I choose these values. Now, why do you think that occurs? I'll give you a second to think about it. Why do these values, these input values, give us outputs that are all integers? Well, think about what we're doing to our input. We're multiplying it by 1 half, which means if the denominator is 2, at some point we're dividing by 2. And what numbers divide evenly into 2? Even numbers. So I plugged in a bunch of even numbers, and lo and behold, I got out a bunch of integers, no decimals, which is exactly what I wanted. Now I have definite identifiable points. So the takeaway here is you must choose your input values wisely. So because I chose my input values wisely, I can plot all these 5 points, and there they are right there, and I have my line. All right, so those are our two methods to interpret slope, to use the slope and y-intercept, and method 2 is to use a function table. Now get out your worksheet, all right, and find the front where we're going to graph the function y equals negative 4/5 x plus 2. All right, let's use method 1 using the slope and y-intercept to graph this line. Pause the video and attempt this on your own, and then we'll walk through it. Pause the video now. Okay, let's see how you did. So let's first identify the slope and the y-intercept. Our slope is negative 4/5, or we could also interpret that as positive 4 over negative 5. And the y-intercept is 2. So we're going to plot the y-intercept and then use the slope to determine a second point. The y-intercept is 2, so we go up here where y equals 2, and we plot that point. Now let's use our first version of the slope, negative 4/5, which means as y decreases by 4, 1, 2, 3, 4, x increases by 5, 1, 2, 3, 4, 5, and that should get us our next point. And there it is right there. Now we could also alternatively use this second interpretation of the slope, positive 4 over negative 5. And let's see if that gets us a point on the same line. So positive 4 means as y increases by 4, 1, 2, 3, 4, x decreases by 5, 1, 2, 3, 4, 5. And sure enough, that gets us another point on the line. We connect our points and we graph our linear function. All right, let's move down. We're going to graph this same function, but this time we're going to use the second method using a function table. So draw up a function table, choose your values wisely, and plot the points. Pause the video now. All right, let's see how you did. So I came up with the following function table first, 0, 1, 2, 3, 4. That seemed easy enough. And sure enough, I came up with values that are not going to be very useful to me. So then I looked at the slope and I asked myself, well, if I'm going to be multiplying by negative 4/5, what kind of values would give me an integer or would result in a product that is an integer? What could I multiply negative 4/5 by? That would give me an integer. And sure enough, if the denominator is 5, that means we're dividing by 5, so probably multiples of 5. Now, let's see. My multiples of 5, starting from 0 in both directions, are negative 5, negative 10, and positive 5 and positive 10. So, and my outputs are all integer values. Now, you might be saying, but not all of these values are able to be plotted on this graph. And that's true. That's true. We're not going to get 5 usable points. But again, we only need 2, so we're fine. So the takeaway there is always choose your input values wisely. So we can only plot negative 5, 6, 0, 2, and 5, negative 2 because the x-axis only goes up to negative 7 in each direction, and the y-axis does the same. So we're only going to be able to plot those 3 points and connect the lines, connect the points and graph our line. All right, let's move on to the next function, y equals 5/2 x plus 4. All right, let's use method 1 to plot to graph the line. Use the slope and y-intercept. Pause the video now and try it on your own. Okay, let's see how you did. So, first step is to identify the slope and the y-intercept. So the slope is 5/2, or alternatively negative 5 over negative 2, and the y-intercept is 4. So we're going to plot the y-intercept, then use the slope to determine a second point. So let's plot the y-intercept, 1, 2, 3, 4, y equals 4, and let's use the slope to find our next point. So as y increases by 5, x increases by 2. Let's increase 5, 1, 2, 3, Uh-oh, that is a problem. See, we actually can't go up 5 because that goes off the graph, and we can't extend the graph further. So what we need to do is we need to use this other interpretation of slope, which is why we spent time learning about how to interpret slope. So instead of going up 5 and over 2, let's go down 5 and back 2. So as y decreases by 5, 1, 2, 3, 4, 5, x decreases by 2, 1, 2. And we get our second point. And we could continue this. We could go down 1, 2, 3, 4, 5, and over 2, 1, 2. But all we need are 2 points. And we can graph our line. And sure enough, we've graphed our linear function. Now let's try the same approach using method 2, using a function table. Pause the video now and try it on your own. All right, let's see how you did. So again, I'm going to give you an example of a poor choice, 0, 1, 2, 3, 4. That doesn't always work for you. We've got 11.5 and a 6.5. So again, I'm going to look at my slope and I'm going to see what am I dividing by. I'm going to divide by 2. So what kind of numbers might I try? That's correct. Even numbers. I have chosen my inputs wisely. So now I plot all of my plottable points on the graph. And sure enough, there are my 3 points that fit on the graph. And I connect my points and I have my line.